Hi, this is section 4 of chapter 1, solving absolute value equations. This is part 2 of this section. In the last section we covered part 1, which is about solving simple absolute value equations and the absolute value properties. So if you're coming from that video, then this is the right video to move on to. In part 2 we're going to cover solving harder absolute value equations, and we're also going to learn about identifying special cases that arrive when solving these equations. So we have this equation which says that negative 2 times the absolute value of 5x minus 1 minus 3 equals negative 11. To solve this equation, we will first isolate the absolute value expression by using inverse operations. So we can do that by adding 3 on each side of the equation first. And by doing so, we get negative 2 times the 5x minus 1 equals to negative 11 plus 3. And negative 11 plus 3 is negative 8. So now we can divide each side of the equation with that coefficient of negative 2. So we divide by negative 2 on each side of the equation, and we're left with absolute value of 5x minus 1 equals to negative 8 over negative 2. And negative 8 over negative 2 simplifies to positive 4. So we know by property of absolute value equations that this expression, the absolute value of 5x minus 1, will equal to 4, and it will also equal to 5x minus 1 equals to negative 4. And then we just have to solve these two linear equations. So we get 5x equals to 4 plus 1, which gives us 5. And then here 5x minus 1 equals negative 4 can be translated into 5x equals negative 4 plus 1, which gives us negative 3. And here we get x equals to 1 if we divide by 5 on each side. And here we get x equals to negative 3 over 5. So we know that the two answers for this equation are x equals to either 1 or negative 3 over 5. So now let's look at even more harder equations of absolute values. So say we have two absolute value expressions that equal each other. Let's say we have absolute value of ax plus b equals to absolute value of cx plus d. So this is a different property, and if we solve this equation we get that ax plus b equals to negative times parentheses cx plus d, and equals to ax plus b equals to positive times cx plus d, or just cx plus d simply. So let's solve this expression that we're given, that the absolute value of x plus 8 equals to another absolute value expression 2x plus 1. So to solve this equation we can apply this property that we just learned, and if we apply it we get that the x plus 8 comes out of the absolute value, and that equals to 2x plus 1. And for the other part of this equation we get that x plus 8 equals to negative times 2x plus 1. And then we could just solve these two equations using the inverse operations. So here on this equation we can subtract x from each side, and we can also subtract 1 from each side. And then we simplify this equation and we get that the x and the negative x cancel out, and the 1 and the negative 1 cancel out. So here we're just left with 2x minus x, which is 1x, and here we're left with 8 minus 1, which is 7. So we know that x is equal to 7 is one of the solutions. On this equation we have that x plus 8 equals to negative times 2x plus 1. So we can apply the distributive property to simplify this side of the equation. So we get x plus 8 equals to negative times 2x, which is negative 2x, plus 1 times negative 1 is negative 1. And then we just solve this equation like this. Here I see that I can add 2x on each side, and then the x's can be cancelled out here. And from here I can subtract 8, and also from here. So the 8 and the negative 8 cancel out, and here we're left with negative 9, and here we're left with 3x. So now we can just divide each side of the equation with 3, giving us that x is equal to negative 3. So here I have case 1, which says that the absolute value of 3x minus 2 equals to x. Using the property of absolute value equations, we know that we can write this absolute value equation into two separate equations, which give that 3x minus 2 equals to x, positive x, and we also get that 3x minus 2 equals to negative x. And then we just solve these two equations like linear equations. So let's solve this one first. Well, on this one we can subtract 3x from each side of the equation, and we get that x minus 3x equals to negative 2x. And then I can divide by negative 2 on each side of the equation, giving that x equals to 1. So let's look on this equation now. So I see that I can subtract 3x again from this side and this side. And if I do that, we cancel this out, we get negative 2 equals to negative 4x. And then x is equal to negative 2 over negative 4, which is simply 0.5. So let's check if both of these solutions work or not. So if we plug in 1 for x, we get absolute value of 3 times 1 minus 2 equals to 1. And if this is correct, then we can say that this is a solution. So we know that 3 times 1 is 3, and then minus 2 is 1. So absolute value of 1 equals to 1. And then we know that the absolute value of 1 is simply 1, so 1 equals to 1. So 1 equals to 1 shows that 1 is indeed a solution of this equation. Let's look at 0.5. So if we plug in 0.5 into the absolute value equation, we get that the absolute value of 3 times 0.5 minus 2 equals to 0.5. And we don't know if this is correct yet, so we place a question mark. So 3 times 0.5 is 1.5, and then minus 2 equals to 0.5. And then 1.5 minus 2 is negative 0.5 equals to 0.5. So indeed, this is a solution of this equation, because the absolute value of negative 0.5 is equal to 0.5. Therefore, 0.5 satisfies the equation. And we note that the solutions of this equation are 0.5 and 1. So case 1 shows that there can be 2 solutions. Let's look at case 2 now, which says that the absolute value of x plus 6 equals to 2x. So same, we apply the properties of absolute values, and we get that x plus 6 equals to 2x and x plus 6 equals to negative 2x. So then we just solve these two equations and check if the solutions are correct. So here I can So supposedly these are the two solutions. Let's check if they're correct. So let's plug in 6 first. So if we plug in 6, we get 6 plus 6 in the absolute value, and the absolute value of 12 is simply 12. So here if we plug in 6, we get 2 times 6, which is 12. So 12 equals to 12, so we know that 6 is indeed a solution of this equation. Now let's look at x equals to negative 2. So if we plug in negative 2 in this equation, the absolute value of negative 2 plus 6 should equal to 2 times negative 2. So if we simplify this, we get negative 2 plus 6 equals to 4. And then here we get 2 times 4 equals to negative 4. But this is not true, so we know that this solution is incorrect. So x equals to negative 2 is not a solution. So in this case, we know that we can get extraneous solutions. Extraneous just means like fake solutions. It's not actually a solution. It's just an apparent solution which looks like it's correct. But when we plug in to check if it really is a solution, we get that it's a false equation, so the solution does not exist. So in this equation, x equals to 6 is the only answer. Now let's look at case 3, which says that the absolute value of x plus 5 equals to the absolute value of x plus 11. So again, we apply the properties of absolute value equations, and then we get the two different equations, linear equations, which are x plus 5 equals to x plus 11. And the second equation is that x plus 5 equals to negative times all of x plus 11. Parentheses closed. And then we just solve these two linear equations. So here I see that I can subtract x from each side of the equation, and I can subtract 5 from each side of the equation. And I get that the x's cancel out, and the 5 also cancels out with the negative 5, which gives us that 0 is equal to 11 minus 5, which is 6. And this is not true, so we can say that there is no solution on this side. So we know that we're only going to get one solution because this linear equation didn't produce a proper solution. Instead, it gave a contradiction that 0 equals to 6. On this side, we know that x plus 5 equals to negative times x, which is negative x, and then negative 1 times 11, which is negative 11. And then we just solve this like a simple equation. So here I can add x, and I can do the same here, and subtract 5 from this side and on this side. And the x and the negative x cancel out here, and I'm left with 2x equals to negative 11 minus 5, which is negative 16, and x equals to negative 8. And if I plug in negative 8 into this equation, we indeed will get the same answer on each side of the equation, so this must be a solution. So in this case, there is only one solution. This is the end of this section, and in the next video I will talk about section 1.5. I'll see you in the next video. Thanks for watching.